Okay, question 7 says the equation for the production of methane is C plus H2 yields CH4. So how many grams of hydrogen are needed to produce 20 liters of methane? So again, with these stoichiometry problems, take what you've been given, which is 20 liters of CH4, and it wants to know how many liters of hydrogen can be produced from that. So 20 liters of CH4 is what I was given. Okay, and I'm already in liters. So we know that got to get this out of liters to be able to set up a mole ratio. Really, because this is already liters and I'm just going to liters. When I take it out of liters and put it back in the liters, because liters are the same, it's not like grams to grams where molar masses of the substances are different. Okay, at STP, 1 mole is always going to occupy 22.4 liters of space. So instead of kind of doing a couple extra steps, I can just go ahead and set up a mole ratio because these are equal. I'm essentially going to cancel them out when I've set it up. Okay, which is kind of like this problem from number 2. If you can see, 1 mole over 22.4, and then 22.4 over 1. Essentially, when I'm done with these cancel each other out. So instead of actually converting it to moles, mole ratio, back to liters, I can go ahead and kind of skip that step just to save myself some time. And I can take 20 liters of CH4, set up my mole ratio. So CH4, I have 1 mole because it's by itself. There's no other coefficient. So 1 mole CH4 on the bottom, and what I want to find on top, so liters of hydrogen, which is H2. And there's a coefficient of 2, so there's 2 moles of H2. Okay, so 20 times 2 is 40, and then divide by 1 is obviously 40. So your answer is D, 40 liters. Okay, question 8. In the unbalanced reaction, Mg plus O2 equals magnesium oxide. What is the mole ratio of magnesium oxide to oxygen? Okay, hint, you got to balance the equation first. Remember, in stoichiometry, in order to do these ratios, they have to be balanced equations first. The other ones that we've been working with had already been balanced up to this point, so you have to balance this equation here by taking inventory of both sides and making sure that whatever's on the left of the yield sign equals whatever's on the right. Okay, so if you balance it correctly, you should have a coefficient of 2. That stays the same, and a coefficient of 2. That way it gives you 2 Mg's on both sides and also 2 O's, or 2 oxygens on both sides of the equation. Okay, so once it's balanced, now it asks for a mole ratio of magnesium oxide to oxygen. So I've got to start with this one first because it lists it first. So magnesium oxide, there's 2. Okay, and then I'm going to compare that to oxygen. Well, oxygen, there's only 1 because we understand that there's a coefficient of 1 there. So a 2-to-1 ratio, it can't be reduced any more than this. 2-to-1 is the lowest whole numbers there for that ratio. So D is the answer. Okay, number 9, use the following balanced equation. How many liters of NH3 at STP will react with 5.3 grams of O2? Okay, again, STP is just telling me standard temperature and pressure. It doesn't necessarily change anything for this problem. Later on, when we get into our next unit, this STP will matter because it will affect some of our calculations. But for right now, don't let that trip you up. So I start with what I know, which is 5.3 grams of O2. Okay. Then that's in grams. I want to get to liters. All right. So first of all, I'm going to have to take grams, convert it to moles. So in order to do that, 1 mole of O2 we know is equal to the molar mass of O2. So hopefully you know how to calculate molar mass of O2. It is 31.998. That comes straight from the periodic table. If you don't know that, you can look up on Moodle how to do that. So that cancels grams. Grams leaves me with moles of O2. Now because I'm in moles, in order to get to my new substance of NH3, I need to set up a mole ratio. So NH3 will go on the bottom. NH3 is going to go on the top because it's what I'm looking for. O2 goes on the bottom because that is what I want to get rid of, because that's what I'm in right now, but I want to get to this compound. So NH3, if I look at my equation, has 4 moles. O2 has 7. So now moles of O2 cancel, moles of O2 cancel, leaves me with moles of NH3, but I'm not done yet because I want liters of NH3. So now I gotta set up another conversion factor. I know that 1 liter occupies, 1 mole occupies 22.4 liters of space. So liters goes on top, 22.4 liters of NH3 over 1 mole of NH3. So moles of NH3 cancel, moles of NH3 cancel, leaves me with liters of NH3 is the only units on my conversions now, which is exactly what the problem was asking me to find. So again, if I just want to take a calculator, plug all this in. Yeah, I just like to do it this way. Parentheses, multiply everything on top. So all the numbers you see on top, close the parentheses, divided by all the numbers on bottom, and you multiply them by each other. 7 times 1, close the parentheses. That way you can do it all in one step rather than having to type everything out. So gives you 2.12. So if I look at my answer choices, 2.12 liters is the correct answer. Okay, number 10 should be straightforward, straight from our notes in class. What is a limiting reagent? Well, we know that the limiting reagent is what runs out first, and so because it runs out first in a reaction, it's going to limit how much product can be made. So just like if I had, 2 bags of hamburger buns and 1,000 hamburger patties, well, the buns is a limiting reagent because it's going to run out first and it's going to limit the number of hamburgers I could actually make. So it doesn't really matter how many hamburger patties I had. If I only have a limited number of hamburger buns, I can't make that many hamburgers. So limiting reagent is the reactant, okay? The reactant that determines the amount of product that can be formed. So your answer choice is B. Okay, question 11. For every 6 moles of FeO, there are how many moles of aluminum? Hint, you've got to balance the equation first. So again, we're not going to take much time balancing the equation. Hopefully you can do that on your own. When you balance the equation, you should have a coefficient of 2, 3 here, okay, 1, and 3. Okay, so it says for every 6 moles of FeO, how many moles of there are of aluminum? So I can take what I was given, which was 6 moles, okay, 6 moles of FeO, and I want to know how many moles of aluminum. Well, I'm just going moles to moles, so I just have to set up a mole ratio. So moles of aluminum is what I want to find. I want to know how many moles of FeO did I start with from my original equation. So FeO here has 3 moles. Aluminum has 2 moles. Okay, so moles of FeO cancel. Leave me with moles of aluminum, which is what I wanted to find from my problem because it asked me how many moles of aluminum. Okay, so multiply the top. 6 by 2 is 12, divided by 3, okay, gives me 4 moles for the answer. Okay, question 12 asks, given the following balanced equation, which of these is an incorrect mole ratio? So what you need to do is you need to go through each answer choice and just see if you could possibly make that mole ratio. Okay, so our first one, 1 mole of N2. So I have 1 mole of N2 and 3 moles of NH3. Well, I only have 2 moles of NH3, so this couldn't ever be a ratio according to your balanced equation. So more than likely A is going to be the correct answer, but let's look at the other choices. 2 moles of NH3, well, I have that, and 3 moles of H2, well, I have that as well, so that it could be a correct ratio. 2 moles of NH3, yes. 1 mole of N2, yes. And 3 moles of H2, yes, to 1 mole of N2, yes, that could be another correct ratio. So A is the choice because it is not a correct mole ratio according to that original equation. Okay, so question 13. Use the following balanced chemical equation and ask how many moles of calcium are required to produce 60 grams of calcium phosphate. Well, first of all, you're going to need to start with what's given to you. So you're given 60 grams of calcium phosphate, okay? And then it asks how many moles of calcium are required, okay? So you want to find out how many moles of calcium. So I'm going from grams to moles. So I'm going to start with what I was given first, which is 60 grams of calcium phosphate. So if I look here, it is Ca3PO4 okay? So I've got to go from grams to moles. Well, first of all, I know that 1 mole of Ca3PO4 is equal to its molar mass, okay? So the molar mass of that substance is, I've already calculated, 310.172 grams of Ca3PO4, okay? So that would cancel out grams and grams and leave me with moles. Now last step, because I'm in moles, now I can set up a mole ratio. So I only have 1 mole of Ca3PO4, so 1 mole of that. And I wanted to find moles of calcium. So here, 3 moles of calcium. Okay, those are the units I'm left with. That's what I'm trying to find. So when I plug this into a calculator, the top divided by the bottom, okay, it gives me a 0.581 moles.